Now, many years ago, when I was at primary school, I was introduced to the number system using these wooden blocks. I don't know if these blocks are still used in teaching number, but certainly for older generations, these wooden blocks were the gateway into the world of the decimal system. So you'd have a little block, then you'd have a row of 10 blocks, then 10 rows of 10 blocks, which would make 100 blocks, and then we'd have 10 lots of 100 blocks, which would make 1000 blocks. Now, these blocks would replicate the columns of the decimal system like so. But I must admit at the time to struggling in making any deeper connection between these blocks and the number system we use. And when I looked into this, I found that I wasn't alone. So I thought this would be a good starting point by having a brief look at the decimal system and how these blocks fit into this system. The definition of a number system is a system that uses a consistent notation of symbols known as numerals. And for the decimal system, this is a place value system of base 10 that uses 10 digits 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. And this is the notation that allows us to add up to 999,999. Now, I'm just looking at whole numbers for the time being. I will look at decimal numbers another time. But here's the structure of the decimal system looking something like this. We have a series of columns, each column representing a power of 10. So we have units, tens, hundreds, thousands and so on. And the digits are placed within the columns to tell us how many units, tens, hundreds, thousands, etc. are needed to make a particular number. So how does it work? Well, imagine an event and we count how many people attend the event. Here we have counted 23 people. How can we represent this in our base 10 system? We group the 23 people like this, where we have 2 lots of 10 people and 3 lots of 1 person. Now let's put this into our base 10 structure. So we have 2 lots of tens and 3 lots of units. We can, of course, rewrite the columns to look like this. We write 1 instead of units, 10 instead of tens, 100 instead of hundreds, 1000 instead of thousands, and so on. Again, let's add the digits 2 and 3 into the 10 and the 1s column. So what 23 means is 2 lots of 10 and 3 lots of 1. Or we could write this as 2 multiplied by 10, add 3 multiplied by 1. But what 23 means is 10 add 10, add 1, add 1, add 1. And so, if I was using the wooden blocks, they would look something like this, where we have 2 lots of 10 blocks and 3 lots of 1 block. Here is another example. There are 138 people. Let's arrange these people into the base 10 structure. We see that we have 1 lot of 100 people, 3 lots of 10 people, and 8 lots of 1 person. We can represent this in our base 10 structure like so. We have 1 lot of hundreds, 3 lots of tens, and 8 lots of units. Similarly, we can write this as 1 lot of 100, 3 lots of 10, and 8 lots of 1. Or 1 multiplied by 100, add 3 multiplied by 10, add 8 multiplied by 1. But what 138 means is 100, add 10, add 10, add 10, add 1, 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 add 1. And with the wooden blocks, it would look something like this. 1 lot of 100 blocks, 3 lots of 10 blocks, and 8 lots of 1 block. So when you see the number 1326, what this actually means is 1000, add 100, add 100, add 100, add 10, add 10, add 1, add 1, add 1, add 1, add 1, add 1. Or 1 multiplied by 1000, add 3 multiplied by 100, add 2 multiplied by 10, add 6 multiplied by 1, which we could also write as 1000, add 300, add 20, add 6. And being able to break numbers down in this way can help us in other areas of mathematics. But that's a brief look at how the number system works, and hopefully it gives you some idea of what those wooden blocks mean. Now, of course, I've only dealt with whole numbers, and I will look at decimal numbers another time. But I hope you found the video useful. If you did, don't forget to give it a thumbs up and click the subscribe button if you want more videos. Thank you for taking the time for watching.